give something like 3 questions from this test for the final, because we are going to learn a new method to do all of them. So we just want to review now the old one and the new one together. Okay, so this is it. Number one, you want to solve the equation, but the method is given to you. Okay, and the determinant coefficient. So solve each equation. Okay, solve each equation by, that's it. Because you have 2 choices, variation of the parameter and the determinant of the coefficient. When the instruction is given to you, you have to go with the given instruction. Otherwise, you are free. You can use any method you like. Okay, that's it. We have 2 here. I try one of them. If you get time, I'll go the second one as well. And we have a solution in the poster. So that's a y double prime plus a 4y equal to 3 sine x. Now that the condition for this method is homogeneous one should have constant coefficient, and the R of x can be only sine x, cosine x, a polynomial or exponential function, nothing else. These are the restrictions. So what you have to do is you have to solve the homogeneous one first. Okay, so you're going to solve this equation first, y double prime plus 4y equal to 0. Okay, because the characteristic equation would be r squared plus 4 equal to 0. So that will be r squared equal to the negative 4. Change it to the 4i squared, and your solutions are going to be complex, positive, negative 2, 1. Okay, pick one of them, the positive one, r equal to the, we call it 0 plus 2i. So this is going to be your alpha plus beta I. So your alpha is 0, your beta is 2. Okay, so the solutions are going to be y is equal to the C1 e to the alpha x. There is no alpha, alpha is 0. So it's going to be just C1, okay, C1 cosine of the 2x. That's C2 sine of the 2x. So this would be your YC. First part. So the YC is going to be C1 cosine of the 2x plus C2 cosine of the sine of the 2x. Any question? We're done with the characteristic equation or the homogeneous. Now you have to find the YP. The information is that your R of x, okay, your R of x is going to be 3 sine of x. Remember, we're just changing the polynomial. The polynomial over here is a constant polynomial. So you have to create a constant polynomial, one for the sine, one for the cosine, okay? So suggestion for the YP is going to be, for example, A1 sine of x plus A2 cosine of x. You check it if there's going to be any duplication case, there is nothing to worry about. Because that's a cosine of the 2x and the sine of the 2x, which is different from sine of the x and the cosine, okay? So checking is completed. Now you have to find the derivative, substitute into the original equation, find the A1 and A2. Okay, any question? So there is no duplicated terms, so you don't have to multiply this one by x or x squared. So find the y prime. Y prime would be A1 cosine of x. Okay, and this is going to be minus A2 sine of x. You differentiate again because you need y double prime. So checking y double prime, if you have a cosine would be negative sine, so negative A1 sine of x, and this would be negative A2 cosine of x. Okay, drop them back into the equation and get the result. So this is the original equation, y double prime plus 4y equal to the 3 sine x. So we are going to substitute. Y double prime would be negative A1 sine of x minus A2 cosine of x plus 4 times y. I do it right away, 4 times y. It's going to be 4a1 sine x, okay, plus 4a2 cosine x. And this is equal to the 3 sine x. So, combine like terms, you have to write down in terms of the sine and the cosine, and let the coefficients from both sides to be equal to each other to be able to find it. Okay, so over here, you have negative a1 and plus 4a1 sine. So the result would be 3a1 sine x. Okay, and for the cosine, negative a2 and positive 4a. Okay, 4a2. So that give you plus 3. Okay, 3a2 cosine of x. And this is equal to the 3 sine x. You may think about it, 3 sine x plus 0 cosine x, and let the coefficients of the equal terms to be corresponding term to be equal to each other to get your result. So from the first one, that give you 3a1 equal to the 3. Okay, that's the first one. And from the second one, we get 3a2 to be equal to the 0. So the first one give you a1 is equal to the sine x, and equal to the a1 equal to 1. Okay, a1 equal to 1. And from the second one, we get a2 equal to the 0. Okay, so your yp would be just sine, okay, your yp would be just sine x. Okay, because the a1 is 1 and the a2 is 0. So yp is going to be equal to the sine x. Okay, we have the yp and the yc, so the final answer, y equal to the yc plus yp. And the yc is c1 cosine of the 2x plus c2 sine of the 2x plus sine x. So that gives you the final answer. Any question? So this one was safe, okay, nothing to worry about. But they usually give you something that is going to be a duplication term. Okay, I'll give you a hint for the second one quickly too, because some of you missed it on the quiz. Any question? So when it's a sine and a cosine, remember, you have to have a combination of sine and a cosine together. So quickly, I form the part 2 to get that duplicated term. Should you have no difficulty, but they give you what? Okay, so that is 1b. In 1b, you have y double prime plus 10y prime. Okay, plus 10y prime plus 25y. 25y, and it is equal to the 14 e to the negative 5x. Okay. Again, solve the homogeneous one. Solution. Homogeneous one is y double prime, 10y prime plus 25y. So characteristic equation r squared, 10r plus 25. You factor it, that give you, repeated factor. Because that would be r plus 5 times r plus 5. Or r plus 5 squared, okay? So you are going to have r equal to the 5 and equal to 5. Repeated solution.
Negative 5.
Oh, negative 5, thank you. Negative 5. Okay, negative 5 and negative 5. Okay, so the yc is going to be the first one, c1 e to the negative 5x, and the repeated solution, c2 x equal to the negative 5x. This is going to be homogeneous. Okay, any question? So we need the yp. Yp, but your r of x is a constant polynomial 14 times e to the negative 5x. So the form of the yp is going to be, you replace you get a constant polynomial with an undetermined coefficient, which is going to be a1 e to the negative 5x. Check this one, there is a term is duplicated. So you have to multiply by x. Okay. but you arrive at x a e to the negative 5x, which is repeated here again. So you have to multiply by x squared. Okay, so this is the one that you have to check, make sure you don't miss it. So yp is going to be equal to the a1 x squared e to the negative 5x. This is the suggestion. Any question? Make sure don't miss it. If it's going to be repeated one, you have to upgrade it so that that duplicated term would be removed. So you have to differentiate it, first derivative, second derivative carefully. Substitute, when you substitute all x squared e to the 5x would disappear. You must arrive at the end as just a constant term, okay? So I'm going to differentiate it. Y prime is product rule, derivative of the first times second, 2a1x e to the negative 5x, plus the second first. The second one, exponential function never change. You have to multiply by u prime. U prime is a negative 5 times the first one. So minus 5a1 x squared e to the negative 5x. Okay, any question? Exponential function never change. You get just a negative 5 times that by the first one. So this is going to be yp prime. You go with the y double prime. You have to differentiate this one, derivative of the first times second, 2a1 e to the negative 5x. Second first, we get the negative 5. You multiply that 2, that's going to be 10a1x e to the negative 5x. So that's the product rule for x e to the negative 5x. You repeat it again for this one. The first derivative would be 2 times 5, 10. So minus 10a1x e to the negative 5x. For the second one, you have only a negative 5. So negative 5 times negative 5 would be positive 25. Everything else would be the same. Because of the exponential function never change, there's usually a combination that you can simplify over here, like terms. So this would be unchanged, 2a1 e to the negative 5x. These two terms, you see, negative 10 and negative 10, that give you negative 20. So that give you negative 20. Negative 20 a1 x e to the negative 5x and plus 25 x squared e to the negative 5x. So that's y double prime. I'll go back, substitute. So I'm going to substitute here, y double prime, 10y prime, 25y equal to the 14 e to the negative 5x. Substitute for the y double prime. This is what we have for the y double prime, 2a1 e to the negative 5x minus 20a1 x e to the negative 5x plus 25 x squared e to the negative 5x. Which is what you got for the y double prime.
Wouldn't it be 25 a1 x squared e to the negative 5x?
25. Yes, you are right. We missed the a1 here. Okay, there is the a1 here. Okay, and there is going to be a1 here. Yes, that's it. Now we continue 10y prime. I'm going to multiply by 10y prime at the same time. This is your y prime. Multiply by 10 and you add it here. So 10 times 2 would be 20. So it's going to be 20 a1 x e to the negative 5x and minus 50 a1 x squared e to the negative 5x. Okay, so this is where I substitute 10y prime. Plus 25y, and this is y. So it's going to be plus 25 a1 x squared e to the negative 5x. So all the x times x squared times should disappear. You should have it. Okay, so we check. This would be fine. Sorry, this is going to be equal to, okay, this is equal to the 14 e to the negative 5x. Cancel out those terms. See, that's a negative a1x, negative 20 a1x, and this is positive 20. So these two would cancel out. Okay, that's it. Now 25x squared, 25x squared would be 50 and the 50. So these three would cancel out. Leftover must be something independent of the x here. So the leftover is going to be 2a1 e to the negative 5x, okay, nothing else, equal to the 14 e to the negative 5x. So the coefficient, you can drop e to the negative 5x if you like, or just get the coefficient to be equal to each other. So you arrive at the fact that the 2a1 is equal to the 14, so a1 would be 7. That's it. So yp is going to be 7 x squared e to the negative 5x. This is yp. Any questions? So the final answer, y equal to the yc plus yp, which is yc is c1 e to the negative 5x plus c2 x e to the negative 5x, and the yp is 7x squared e to the negative 5x. And you're done. Okay, so that's the two cases that we have. Just give you one. Just give you one trigonometric one, one exponential one. Okay, that would be your question number one, if you like. Or topic number one for the test. Any question? When the coefficients are constant, you do this problem right at the end of this course. I mean, you do it by your test 3 or even by your quiz 3. So this is where we have learned Laplace transform, and we can apply the Laplace transform to the Laplace transform. We quickly change this one into the algebra. See, it would be something like integration that we're going to have. And the algebraic form is most of the time is a kind of a rational expression. Then you have to break it into part by using partial fractions. That will be your job. It's going to be quite a lot of algebra. Any questions? So that's question number one. Number two, again, we are interested because we cannot give you these type of problems in the higher order because it takes time. So what we're going to do is we are going to only ask you to give us the form of the yp only, okay? So this group, you don't have to solve it. Just give us the form of the yp, okay? So we want you to find a suitable form, possible one. Okay, find a suitable form, like the one that we did for the quiz, for yp of t. Okay, yp of t, of course, if you use the undetermined coefficient method to solve these type of problems. Okay, let's check this, make sure you know. Most of you did all right for the quiz, so it should be able to do it again for us. This is the third derivative minus y prime, and you have 2 cosine of the t plus t e to the negative t. You have to solve remember, you have to solve the homogeneous one to see what would happen when you could do the yp. Can't do it without the yc. Okay, so for the solution, quickly we solve this one first. So this is characteristic equation will be r cubed minus r equal to the 0. Then you can factor out the r, so that give you r squared minus 1 equal to the 0. So you can factor it again, but your solutions are going to be r is equal to the what? Is equal to the 0, negative 1, and positive 1. So you have 2 solutions, and they are not repeated solutions. So you can declare the yc. Yc is going to be c1 e to the 0, which is just a c1, plus c2 e to the negative t, plus c2 e to the t. So that would be your yc. Any question? E to the 0, usually you don't write it down. Now you want to get the yp. Okay, you want to get the yp, and you have a combination of 2 functions. So we do it twice. 2 cosine t plus t e to the negative 2. So the yp is going to be, take care of this one first. It's a polynomial, constant polynomial times cosine. So you have to have a constant polynomial times cosine and the sine. So a1 cosine of the t plus a2 sine of the t. There is no duplication term because these are exponential and these are trigonometric. So we're done with the first part. Any question? Second part, you have a linear polynomial times e to the negative x. So you have to create the linear one yourself. The linear one would be, we go with the a2, so we go with the a3 plus a4 t times e to the negative t. When we check to see what we are going to have. Okay, when you multiply it inside, it give you a constant times e to the negative t. So there is a duplicated case here, okay, because of e to the negative t. So you have to raise it. You multiply by another t. Okay, you multiply by another t to remove that duplication. Okay, this is not the repeated solution, so that would be enough. When you multiply, you get what? You multiply, you get a3t e to the negative t, and we are fine. Okay, that's it. If you want to rewrite it, so the yp is equal. Remember, you just multiply the second part, not all of them together. So the first part is unchanged. And the second part is, that would be fine, but if you want, you can multiply the t inside, a3t plus a4t squared. T to the negative t is going to be your final. Okay, you're not supposed to find those coefficients, of course, it takes time to find it. This one, any question? Do one question, but a couple of these, two of these together. Okay, let's check another one. The second one is interesting, like the one that you got in the quiz. Fourth order, fourth derivative, or the derivative, and 4y double is equal to the t e to the t. It's like the one on your quiz. There is a constant here, and the sine of the 2t. Okay, solve the homogeneous one, which is in this case is interesting. So the homogeneous one is this one. So the characteristic equation will be r to the fourth power 4r squared equals to the 0. To solve it, you have to pull out the r squared. So we pull out the r squared, the leftover is going to be r squared plus 4 equal to the 0. So the solutions are going to be, you see, from the first part, we get r equal to the 0, 0. Okay, and the other part, you have the r squared equal to the negative 4, which is 4i squared. So that gives you r equal to the positive negative 2i. So you have 4 solutions, 2 complex to 1 repeated. Okay, 2 complex, 1 repeated. We can put them together. So what's going to be the final answer? YC. YC is going to be equal to the C1 e to the 0, if you like, write it down. For this one, e to the 0 is repeated. C1x e to the 0, or t, in this case, t e to the 0. Now we get to the complex part. You know, there's going to be just r equal to 2i. Alpha is missing, so cosine of the 2t and the sine of the 2t. So that's a C1, C2. Now we get the C3, cosine of the 2t plus C4, C4 sine of the 2t. Okay, but you check to see if it's going to be the repeated one. As you can see, it's repeated here. Okay. Oh, I'm sorry, that's just fair. That's the YC so far. That is the YC. So I rewrite it. So YC is C1. C1 plus C2t plus C3 cosine of the 2t plus C4 sine of the 2t. So this is your YC. Any question? Now bring the Rx and try YP. Okay, so to get the YP, have a combination of two functions for the R of X, R of T. So, or three functions. You have T equal to T e to the T. It's a polynomial times exponential function. You have a constant polynomial, which is 4. And you have a trigonometric function psi. So you have to consider as the three terms. So you need 3 YP. So YP equal to, take the first one, T e to the T. So a polynomial, linear polynomial. So it's going to be A1 plus A2T times e to the T. That would correspond to the first one. You check to see if it's going to be, there is no duplication over here. Okay, you don't have any exponential term. So we're done. Then a plus 4, just a constant polynomial. Get A1, A2, so this must be A3. A3, but the constant term is in YC. So you have to upgrade it, okay? You have to upgrade it, multiply by T. But if you multiply by 3, you get here, C2T. So you have to multiply by another T. So that gives you A3T squared. Any question? So 4 is a constant polynomial. You introduce a constant polynomial like A3. But A3, the constant term is here. So we have to upgrade it, multiply by T. But when you multiply by T, constant times T is here. So you raise it to the second power, okay? So that would be for 4. Now for the sine, you need a combination of sine and cosine. The coefficient is 1, so just a constant polynomial. So it's going to be plus. You go with A3, so it's going to be A4. A4 sine of the 2T plus A5 cosine of the 2T. And we check to see, you see both of them are here. So it's duplicated here, so we have to multiply by T. Remember, you just multiply this one by T, not all of them together. Okay, take each one of them separate. That's it. So that's a kind of most general one that you can have for this group to get this done. Those homogeneous one is interesting, that may be given to you directly, as we did it on the quiz. Just those repetition solution, okay, 0, 0 here, make sure that you get it right. Okay, that's part B. Any question? So that would be P. We can check the C2 because of the homogeneous equation. Done. So we check part C, and that's a fourth order derivative in part C. That one too. So that would be part C. In part C, this is the equation. Y the fourth order of the derivative, then you have the third order, 5 tiers, if you like. That's the second, 2y double prime. And on the other side, you have a least. This is 3e to the t. That's 2t e to the t minus the negative t, and e to the negative t sine t. 3 terms. Check the homogeneous to see what type of equation is this one. Yeah, you ready? So solution to the homogeneous. So that gives r to the 4th plus 2r cubed plus 2r squared equal to the 0. Carefully, you should solve this. So how are we going to solve it? Factor out? No.
R squared.
You have to factor r squared first, okay? You factor out the r squared, so that gives you r squared. 2r and 2. Okay? Now we can handle the r squared, okay? R squared equal to the 0. So that gives you 2 solutions. You repeat the solution. So you make a note of this, and then You have to take care of the leftover. So what's going to be the leftover? R squared plus 2R plus 2 equal to this. You cannot factor it. So we have to use quadratic formula, probably it's solution of the complex. So this is it, negative B, negative 2, plus or minus B squared, 2 squared, minus 4 AC. A is 1, C is 2, divided by 2A, 2 times 1. Okay, continue on the top. It's a negative 2 plus or minus. 2 squared would be 4. Okay, and this is, that's a 2, 4AC. That's a 2 here, okay? A is 1, C is 2. And so the first one, 2 squared would be 4, and the other one would be negative 8. Okay, negative 8 over 2. So inside the radical, you get the negative 4. The solutions are going to be complex, okay? Radical negative 4 over 2. You change the negative 4 into the 2I squared, you take the square root. Okay, so it's going to be negative 2 plus or minus 4I squared divided by 2. So you arrive at the negative 2 plus or minus 2I over 2. And we can break it as a complex number to get the alpha and beta and simplify. Negative 2 over 2 plus or minus 2 over 2I. So all the 2's will disappear and you get negative 1 plus or minus I. 2 complex solutions. Take one of them and you write the solution. Okay, so you consider negative 1 plus I, alpha plus beta I. So your alpha would be negative 1 and beta would be 1. So 2 solutions from here. 2 solutions. Remember, we have 0, 0 here. Repeated solution. So we are ready to give you the YC. So what's going to be YC? For that 0, we get the C1 e to the 0. It's repeated, so C2 e to the 0. That's the 0. Now the complex numbers. For the complex one, we get the C3 e to the negative t because the alpha is negative 1. Cosine of t plus C4 e to the negative t sine of t. So this would be your YC case. Any question? So you can, this simplify. E to the 0 would be 1. So C1 plus C2t plus C3 e to the negative t cosine of the t. Okay, cosine of the t. And the other one is what? C1, C2, C3, and C4 e to the negative t sine. So this is going to be by C. Okay, we get the C. You are now you are ready to find the YP. So what is going to be the YP? Okay, R of X is what? R of X is 3e to the t, 2t e to the negative t, and e to the t sine t. You have 3 functions, okay? 1, 2, 3. So we have to take care of these all together. Are you ready? What's a YP? So YP is equal to the first one. It's a constant times e to the t. So it's going to be just a constant times e to the t. E to the t is not duplicated case and be done. Then you have a linear polynomial that e to the negative t. So we have to create a linear polynomial. It's a a2 plus a3t. Okay, a2 plus a3t times e to the negative t. We check again, this is not going to be a repeated term. E to the negative t comes with the cosine. It's not coming with the t. Okay. So we are safe. You don't do anything. We go to the next one. Going to the next one, you have to give us is a constant coefficient times e to the negative t sine t. Yes.
Sir, does for the a2 plus a3t, if you FOIL in the e to the negative t,
Okay.
would that match with c3 e to the negative t, or do we
No,
not?
no, because you have e to the negative t cosine.
Okay.
It must be a single one. It must be separated term.
Separated. Okay.
Yes.
Why for that one, the two t e to the negative t, why do you not need a constant term? For like the first one, you have the a1.
No, you see, the first one is a constant polynomial. 3 is a constant polynomial. So you replace it by a constant polynomial with undetermined coefficient, which is a1. Okay? But this one, this 2t altogether is a linear polynomial. Okay, it's like 2t plus 0. Okay, that's going to be the one. Just like the equation of a line.
Thank you.
Okay? Any question? Now, this one here. This would be tricky. Over here, you see, you can think about it as, again, you focus on that exponential part that you have, and it's the sine and the cosine. So this is going to be something like, the coefficient is constant. So a2, a3 now it's going to be a4. a4 e to the negative t sine of t plus sine and cosine comes together plus a5. a5 e to the negative t cosine of t. Okay? Now you check to see if it's going to be duplicated case. So it's duplicated here, you see. E to the negative t cosine and e to the negative 2 sine. So this last one you have to upgrade it. So the last one, just multiply by t and do that. Okay, so they must be combined together to be considered as a repeated factor, if you like, in these numbers. Okay, so the first one is just a polynomial, a constant times e to the t, a constant times e to the t, a known constant. The second one is just a polynomial of the first degree, if you like, 2t. So you have to write the polynomial of the first degree, a1, a2 plus a3t, okay, times e to the t. This is going to be the case. This is not repeated because the e to the negative t and the cosine are stay together. Then for the sine t over here, we just get a coefficient. So we change it to the a4, e to the negative t sine t, but you have to bring the cosine at the same time. So that would be the duplicated case. So we multiply by t, and that gives you the final answer. Okay, any question? So three very good examples. Now, you have all the possibilities that you may face, if you like. So that is going to be question number 2. Topic number 2, finding the yp. Okay, the equation, the homogeneous one would be higher order because this is the way we're going to check those higher order. So you have to solve the homogeneous one. You get 50-50 for the points when you do this one. So you don't do it YC, you don't have any idea of what is going to be the case. Okay, so that's the first method. Any question? The next method is variation of the problem. Okay, you one or two of these terms. Okay, they are popular. You will see 2 automatically because you get 1 directly, and you get 1 with the Cauchy-Euler equations. Okay, so you see 2, but 1 directly. Number 3 is 1, but I do 4 for you. If I get time, I explain number 3. Number 3 is the best equation. You should see it. Okay, it's very, very, very unique. But the varieties are going to be number 4. Okay, so we have a nice one in 4. Kind of all the possibilities really. So the one that you see is going to be very similar to this. So solve each equation. The method is variation of the parameter. Okay, by variation of parameters. You know that. You are going to find the YC. YC would be C1 Y1 plus C2 Y2. We change the C1 and the C2 into U1 and the U2. We're going to find the U1 and the U2, come back and do the YP. Okay, so checking the first one. Okay, that's it, Y double prime. That's Y equal to the 10x. It would be 10x secant x, the variation of exponential function. These are the most popular ones. Okay, there you go. You have to solve the homogeneous one first again. Solution. So check this one first. Carefully solve it. It's a would be constant coefficient. If it's not going to be constant coefficient, they have to give you the solution. It's bad, they give you the constant coefficient. It's going to be r squared plus 1 equal to the 0. Okay, r squared equal to -1. It's complex. We call it I squared. So r would be positive negative I. So you get the positive one, identify the alpha beta. So this is going to be the 1. So 0 plus 1i. So alpha beta I, just explain, you do it right away. Alpha is 0 and beta is 1. So your YC is going to be simply C1 e to the alpha x would be just 1. So C1 cosine of x plus C2 sine of x. So this would be your, okay, this is going to be your YC. Okay, now the YP. In order to get the YP, so the YP is this. Your function is tangent, so there is no chance you'll be able to solve it with undetermined coefficient. Because undetermined coefficient can be applied only you get sine or cosine. But in fact, they give you the method, variation of the parameters. So you have the hint, okay? So what we're going to do is, in order to get it, variation of parameter method. This is it. YP would be U1 Y1 plus U2 Y2. To identify your Y1 is cosine of x. Your Y2 is your sine of x. Okay. So these are going to be the one that you have. And then you have to identify R of x. When you identify R of x, be careful, the coefficient of y double prime must be 1. So if it's going to be anything else, you divide it. In this case, this is fine. So that gives you tangent of x. Okay. Now the formula, just remind you, U1 is negative. Y2 R of x over the Wronskian. Okay, dx, and the U2 is Y1 R of x over the Wronskian. That's your formula. Okay, we have to find the Wronskian first. So the W, Wronskian, is Y1, Y2 prime minus Y1 prime, Y2. So we have to bring those derivatives. There you are, Y1 is cosine of x. So Y1 prime is negative sine. Okay, Y2 is sine of x. So Y2 prime is cosine of x. Carefully substitute. So W would be Y1 is cosine. So it's a cosine x times the Y2 prime is cosine. Minus, okay, minus Y1 prime. Y1 prime is negative sine. Negative sine times Y2, which is sine again. So the first one would be cosine squared. That's a negative positive. That would be sine squared, which is 1. So if your Wronskian happen to be something seems to be complicated, probably you missed the sign or something. Must be just a single nice step.
For
So
the
that's
Wronskian would only be nice and pretty if it's a trigonometric equation, though.
yeah.
Okay.
All of them will be nice.
Okay.
1 over x, x squared, this type.
Okay.
If it's going to be something The line one, probably you missed something. Okay, so this is it. Now we are ready. Going back and getting the U1 first. So U1 is integral of negative y2. Y2 is sine, so negative sine x. Times the r, which is tangent of x. Divided by the Wronskian, which is 1. That's it. So we get negative sine x. This is going to be negative sine x, tan x. Okay, tan x dx. Have to integrate it. You see, you may change this tangent into the sine, cosine, or some other methods to do it. Okay, so it's going to be negative. You may try. That would be sine x over cosine x. This is one version to do it. Okay, so you arrive at sine square of x over cosine x dx. Any suggestion? Use up. Yeah. Use up. How? Use up won't be used now. Yes.
Pythagorean identity, change it to 1 minus cosine squared x.
Yes, that's good. Yeah, sine squared 1 minus cosine squared to be able to break it first. Then that would be something. Okay. So just apply the options that we have. There's a negative here, of course. So it's going to be negative 1 minus cosine squared. Okay, divided by cosine x dx. Now you break it. Okay, you break it into fractions. 1 over cosine, which is secant. And this is going to be cosine square of x over cosine. Okay, so you arrive at integral of a secant x minus cosine x. Cosine x dx. How it can be done. Any question? So you must remember the integral of a secant, okay? So U1 is going to be negative. Integral of a secant, you remember? Yes,
Natural log secant plus tangent.
see it, natural log, absolute value of secant x plus tangent x. Yes, make video now. You may bring it because secant and secant cube is part of the game for this variation of the problem. Secant and secant cube. Of the time, you come. So, and then the other part, integral of integral of a cosine is going to be sine. Negative would be positive, so it's going to be plus sine x. Remember, no constant there because this is particular solution. Okay, so that would be U1. Okay, so that would be U1. Now we are going to repeat it again to get the U2. Okay, any question? When you do a couple of them, then you quickly get the idea of how you change the sine, cosine.
Yeah.
There are not many cases, but they are connected to each other. Okay, let's go and get the U2. For the U2, you have the Y1 R of X. That would be easy, it would be simplified. Yes. So we go with the U2 now. So the U2 is going to be integral of Y1 R of X over the Wronskian. So we substitute. Our Y1 is cosine X. Okay, so this is cosine X. And R is tan X. And the Wronskian of 1. No, that's tan is sine over cosine. You simplify this. So that you will cosine X times sine X over cosine X. So the cosine would cancel out. So that give you integral of the sine, which is a negative cosine. And no constancy, yes.
At the end of each problem, do you want us to rewrite it every time, or can we just say like YP is this, YC is this, and then just like at the bottom, write Y equals YC plus YP?
Oh, yeah. But
Just like, so we don't have to rewrite it at the end each time. We can just say, oh, this is
Yeah,
YP.
at the end you say YC plus YP, we accept it. Yeah. But you have to simplify the YP for these cases.
Do we have
You
to
have to
simplify?
find the YP.
Do we have to simplify it?
Where is your YP?
That's what we've been doing.
I mean,
It's U1.
No, you have to find it. You are not done yet.
well, I mean, at the very end, like, can we
No,
just,
the only thing, yeah, that,
Okay.
and we have YC and YP, yes. Why is it the vice versa?
Simplify YP.
okay,
Yes, it's the way I do it myself as well. Yeah. That You have to give it. You're not done yet.
and then have to simplify it. It's like,
We're not done.
Okay, you need to do it because you have to do it several times.
We have to find the constant.
Okay. And this is your, your star part of the problem to write it down. And yeah, I know that for the variation of parameter, you will see, sometimes it's so, okay, the solution is so boring that you don't like to repeat it again. But yes, if you get to that part, yes. Let me just finish, I tell you. What I do. You see, you are not done yet. You have to simplify the YP. See, remember? YP is what? We are not done yet. The YP is this. Your suggestion was U1, Y1, remember? That's U2, Y2. You have to substitute and simplify to give us the YP. So it's going to be equal to the U1. Remember, the U1 is, what is U1? It's a negative ln of the absolute value of the secant x plus tan x, okay, plus sine x. This is your U1. Multiplied by your Y1, which is cosine x. Okay, plus your U2. Your U2 is negative cosine x. Tangent by Y2. Your Y2 is sine x. Okay, then you multiply, you see, when you multiply these two, cancel out. So the YP would be negative ln of the, negative, I put the cosine up in front, so it's going to be negative cosine x ln of the absolute value of the sine x plus tangent of x. You see this one? You have the sine cosine minus cosine sine. So this will simplify.
Shouldn't it be secant x tan x? On your YFP line, you have sine x. The
This
next
one?
line, yeah, on the next line, you wrote ln sine x plus
Oh, let me
tangent x.
see. So that is the sine, and what's the Y1?
If you go back,
Y1 is cosine.
On the last line you wrote sine x plus tan x,
Inside
under
that
that line,
This one?
inside the absolute value.
Oh, this one. Oh,
Yeah.
All right, thank you. Secant, yes. So YP would be, eventually, YP is negative cosine x, ln of the absolute value of secant x plus tangent x. That is the YP. Yes, now you can say that y is equal to the YC plus YP. Accept that if you write it down. And it's not bad. Repeat it. Okay, cosine x, sine x, minus cosine x, ln of the absolute value of the secant x plus tangent. You see, that would be the general solution of the equation. Okay, so manage your time. The case of the variation of parameter takes time to do it at any level. It doesn't matter whichever is given to you. Okay, so this is the case with the tangent. We have the case with the secant is, I think I did the same case with the secant property. So I do it. I come back and do more for you to get this. Because there is a couple of them, even from a report. You want to integrate it, you'll be in trouble. Okay, I can give you a break now if you like. Come back and more. You have to do Euler, Cauchy Euler, and the nonlinear.
I tried getting this, my other shoulder.
I know. It's not.
We got the,
As long as you know that.
that recycled water bottle.
But you hate them.
It's around it, we're 3D the parts. Yeah, and the inventor
Definitely.
is gonna offer to give us like a video call.
Hmm. It always looks kind of gross because it's like so many colors, but it's so delicious. Oh, I want a snack.
Still trying to figure it out.
I'm not gonna eat a snack.
Save 70 calories for tomorrow.
No, for more pasta or extra Parmesan cheese on top.
Some change.
Although I don't know if feta and parm go good together. I don't see they would.
Pizza.
Extra little bit.
Yeah. It's supposed to take 20 hours. The print was supposed to take 20 hours. But that estimate came from a person.
Yeah, procedures are slow.
Yeah.
My mom. Yeah, ABS. I did 35% infills at first, but like they were like a little wobbly, so I did 100% after, and they were a lot more sticky. Professor, is this exam gonna be hard
Or what?
for for Tuesday?
No, it's not.
It's gonna be easy?
Oh,
It's gonna be easy?
no,
No?
no, it's not hard.
Okay,
It takes time. Just make sure they know.
okay.
Can we come a little early again?
Yeah, yes,
Yes. What day is it?
Tuesday.
Tuesday?
Oh, yeah, Tuesday. I can come in. Yeah, you must come early. That's
Okay.
why. I'm gonna come early. Takes.
Okay,
I'll be here in Tuesday. Yeah, I'll be here 30 minutes early.
okay.
So I cannot give you time after that. I have class.
What class?
Huh?
What class?
Calculus 3.
Oh, do you teach multiple?
Yes.
Oh,
Teach at Palmer.
oh, I see. How many classes do you teach in total?
In total. Infinitely many.
Oh, wow. I didn't know it was possible.
No. My contract with the university, I have to teach three classes each semester over there.
That's cool.
And then, if I get time. Yeah, like, calculus 3, linear algebra, discrete mathematics.
What's your favorite class to teach?
To teach, I like all of them.
Or like, do you have a favorite?
Linear algebra,
Oh, I haven't taken that one.
that's the one.
I want to take discrete.
Discrete is the easiest one.
Oh, yeah.
I teach it in summer.
Yeah.
It's online.
I'll probably take it if I stay here another year.
Yeah, discrete is different, but it's interesting. But linear algebra really is the one that everything based on that one for future.
Mhm.
But calculus 3 is between the calculus 3 is the, it's very, very interesting.
I like calculus too. So fun.
Yeah. it's, So the second one that you have over here for variation of parameter is not bad. We can check it quickly, but the other 4 takes more time. Okay, make sure check the solution when I post it for you. Okay, because in the review that I did the last semester for the class, I just did part 1 and 2, but I add 4 more for you. So when I post the solution, check it. So a couple of them when you want to do the integrations. Have a look. Okay, so again, I can do the second one as well because exponential one is very popular. Okay, so this is going to be 4B. Okay, so 4B, again, the variation of the parameter. equation is this one, y double prime plus 2y prime plus y equal to e to the negative x and over x. X is a possible. Okay. Again, the only choice that you have is variation of parameters. Constant, the coefficients are constant, but this function is not x times e to the negative x, it's e to the x over x, okay? So again, we have to solve the homogeneous one first, okay? So we go over the y double prime, 2y prime plus y equal to the 0. So that give you r squared 2r plus 1 equal to the 0. So we have a repeated solution. Does that give you r plus 1 square or r plus 1 plus 1? So in that case, you are going to have r equal to the -1 and -1, okay? So that would give you a repeated solution over here. Okay, so there you are. So we can identify your y1 here. So the y1 would be e to the negative x. Y2 would be x e to the negative x. And your yc is c1 e to the negative x plus c2x e to the negative x. Okay, so that's the first part. Now we have to find the yp. Okay, yp, variation of the parameter. So yp would be u1 y1 plus u2 y2. And we identify the r of x. R of x, the coefficient of y double prime is 1. So that would be e to the negative x over x. Okay, now we have to work on the Wronskian. Okay, so we want to find what is the w. So there you are. We have the y1 is e to the negative x. We get the y1 prime. E to the negative x. Y2 is x e to the negative x. So y2 prime, the product rule of the first times second negative x. Second first is going to be negative x e to the negative x. Okay. I'll go with the Wronskian. Wronskian is y1, y2 prime minus y1 prime, y2. Substitute y1 would be e to the negative x. Okay, y2 prime is going to be e to the negative x minus x e to the negative x. Okay. So that would be y1, y2 prime minus y1 prime, which is negative e to the negative x times y2, which is x e to the negative x. Carefully simplify. Okay, multiply across here. E to the negative x times e to the negative x would be e to the negative 2x. Okay, minus x e to the negative 2x again. Negative would be positive. So we have x e to the negative 2x. This x e to the negative 2x and e to the next will be canceled out. So we get e to the negative 2x. Now that the Wronskian must be a non-zero number and exponential function never zero. So the Wronskian is e to the negative 2x. Okay, any question? So now we bring the U1 and the U2, see what type of format are going to be. So we go with the U1, which is integral negative y2 rx, Wronskian, and the dx. Okay, it's going to be integral of negative y2. So y2 is x e to the negative x, so it's going to be negative x e to the negative x okay, times the Rx. So your Rx is what? Your Rx is e to the negative x divided by x. Okay, and the Wronskian is e to the negative 2x. Add the dx. Okay, carefully simplify it to see what's going to be the result. So to simplify it, these x and x would cancel out. Okay, you have e to the negative x times e to the negative x, which is going to be, you see, negative, you add the exponent. So that gives e to the negative 2x on the top. And you have e to the negative 2x on the bottom, dx. Now we simplify it. So you simplify that, giving negative 1. So it's going to be negative dx, and integral of negative 1 is a negative x. So u1 would be negative x. Okay, any question? So going for the u2 now. So u2 would be integral of y1 r of x over w dx. So it's going to be integral of y1. y1 is e to the negative x. That's your y1. Your r of x is, you see, r of x is e to the negative x again over x. And you have the e to the negative 2x for the Wronskian. Now, the top e to the negative x times e to the negative x would be e to the negative 2x. So this is going to be integral of e to the negative 2x on the top divided by x, and then divide by e to the negative 2x dx. Now e to the 2x and e to the 2x would cancel out. The leftover on the top would be 1. So that gives you integral of 1 over x dx, which is ln x. Okay, so u2 would be ln x. Any question? So they're not difficult, but you get these involved, double check. We get it right. Now we have the u1 and u2. Nicely, we can write the yp. Okay, yp. u1 y1 plus u2 y2. Substitute, simplify. u1 is a negative x. It's a negative x times the y1. y1 is e to the negative x. Plus u2 is ln x. ln x times the y2. y2 is x e to the negative x. There is nothing to simplify. So the yp would be simply negative x e to the negative x, okay, plus x e to the negative x ln x. Okay. So y equal to the yc plus y2. Okay, so these are the type that you get. And check for the other 4 parts that we have, okay? Check my solutions. A couple of them, when you want to integrate it, it would be good to see it, to see what would be the integral for situation. And we give you something similar. So that's a variation of the parameter method. Okay, one question directly, and get one from the Cauchy, okay, Euler. So in fact, you are going to have 2 solutions. 2 questions on this one. Okay. So the next one is Cauchy Euler. Very easy case. You give it 2, one homogeneous, one non-homogeneous one. You know that you change it to the constant coefficient and can be done nicely. So the next case is number 5. Number 5 is Cauchy Euler. Okay, that's it. Cauchy Euler equation. In cases, homogeneous. So case 1, you want to solve this equation. is x squared. Okay, x squared y double prime minus 4x y prime, okay, plus 6y equal to 0. Remember, the solution of this type of equation are of the form of x to the r. So we assume that the solution is x to the r. You substitute, you get a characteristic equation. To solve that equation, there are three possibilities. With real solutions, okay, repeated solution or complex. So most of the time for this case, we go with the complex when it's given to you. But let's see what's going to be the result of this one, okay? So this is it. The solution is going to be, you are going to suppose y, there was a formula that we proved, but I prefer to substitute. If you want to memorize that formula, it's up to you. Okay, I replace, suppose y equal to the x to the r, so y prime would be r x to the r minus 1, and y double prime would be r times r minus 1, x to the r minus 2. Okay, you substitute these into the equation, and all the x's would disappear. So going back to the equation, substitute here. Okay, so that gives you x squared, y double prime, it's r, and r minus 1, and x to the, okay, r minus 2. Minus 4x, y prime is r, x to the r minus 1. That's a 6y, 6 x to the r, equal to the 0. Okay, all the x's, drop them. Okay, drop. The leftover equation in terms of r. So from the first one, we get r times r minus 1. From the second one, we get minus 4r. And from the last one, we get 6 equal to the 0.
That always work out that way.
That's it, yeah, all the time, yeah. Carefully, just make sure you don't get this, especially if there's going to be any sign. So simplify it, distribute r squared minus r minus 4r plus 6 equal to the 0. Combine the like terms, r squared minus 5r plus 6 equal to the 0. That's a characteristic equation that you have to solve it. Three possibility for this one. Okay, real solutions, two different solutions, repeated solution, or complex solutions for this type. So this would be, you need two numbers with a product of 6 and a sum of 5. Okay, so the possibility is going to be 2 and 3 in this case. Okay, so it's going to be a real solution. So you get r minus 3 times r minus 2 equal to the 0. That's the result from the case. So we label the points as r1 equal to 3 and the r2 equal to 2. So that one is easy, two distinct solutions. So correspond to this one, you get the y1, which is x cubed, x to the r, and this would be x squared. So your solution is c1 x cubed plus c2 x squared, and you're done. Okay, that was the easiest case. But the case when the solution is going to be repeated or complex are more popular. Okay, that's a homogeneous one. We give you one homogeneous. Any question? Now the big one is when it's a non-homogeneous. It takes times, okay? Right, we give it one. So that's the number part B. Non-homogeneous one is this one. X squared y double prime minus 2x y prime, okay, plus 2y equal to the x cube ln x. See, that's a non-homogeneous case. Now, the way you do it, you make it 0 first, you find the homogeneous one first. Then you come back and use method of variation of parameter only, because the coefficients are not constant. Variation of the parameter. And you got to be careful that r of x, you see this one? When you want to pick r of x, you have to divide this one by x squared all the time. If your integral getting complicated, probably you miss this one. Okay, so make sure you know it. And be patient to solve this, solve it through. So that's it. We go with the homogeneous one first. X squared y double prime minus 2x y prime plus 2y equal to 0. Again, introduce your solution as x to the r. So y prime would be r x to the r minus 1. The y double prime would be r times r minus 1, x to the r minus 2. Again, substitute the, cancel out the x's, get the r. So that would be x squared y double prime is r times r minus 1, x to the r minus 2, minus 2xy prime, r x to the r minus 1, okay, plus 2y, 2x to the r, equal to the 0. Cancel out all the x's, so that would be out, because all of them would be x to the r. So, this is it. What's going to be the leftover? The leftover are going to be r times r minus 1. Get the minus 2r here, okay, minus 2r, and plus 2, equal to the 0. Okay, so the x's disappear. You multiply this one, combine the like terms, solve the resulted equation. It's going to be r squared minus r minus 2r plus 2 equal to the 0. So combine the like terms, r squared minus 3r plus 2 equal to the 0. Again, easy equation to solve. Get the two real solution again. So this is going to be r minus 2 times r minus 1 equal to the 0. So we have two solutions. You call r1 to be equal to 2, r2 to be equal to 1. So the corresponding solutions are going to be y1 would be x squared, y2 would be just x. And the yc for this one, yc is c1x squared plus c2x. This is, okay, the first part. Of course, we know that if this solution is going to be repeated, solutions are x to the r ln x, depends on the given one, okay? But then mostly when it's a non-homogeneous, it's going to be just distinct real solutions because, it takes time. Okay, so that's the homogeneous one. Any question? Now you have to use a method of variation of parameter to find the yp. Okay, so I'm going to go to the next page. Are you done? Get this true. Okay, so the next step is going to be, you want to find the yp. That's it. You want to find the yp. So you have to identify r of x, but remember, you divide by the coefficient of x squared. See, r of x is x cubed ln x. And you divide it by the coefficient of the y double prime, which is x squared, all the time. Don't miss it. Okay, then it's going to be x ln x. So you have to use x ln x for the following, okay, integrations. Not this, okay? Now, with the variation of the parameter, you know that it's going to be u1, y1, that's u2, y2. You identify your y1, okay? Take the y1 to be, okay, x squared and the x. y1 is x squared and the y2 is x. That's it. I'll start the procedure up there. Okay, yes.
Why do we divide by x squared?
Because in the formula that you have for the variation of the parameter, remember the coefficient of y double prime is always 1. Then you prove the theorem. Remember, y double prime plus pxy plus qxy. So you have to, normalize it to say. Okay, so get the run scan first and continue. To get the run scan, we need the y1 prime. It's a 2x, y2 prime is 1. Get the run scan, y1, y2 prime minus y1 prime, y2. Substitute. y1 prime is a 2x, it's a 2x times 1 minus, sorry, y1 is x squared. It's x squared. Y2 prime is 1 minus y1 prime is a 2x times y2, which is x. So that gives you x squared minus 2x squared, which is a negative x squared. Okay, so in this case, this would be your get the Wronskian of a negative x squared. This is not zero number, okay, it's positive. We go with the Cauchy Euler, so this is a non-zero number, and we are safe. Any question? Yes,
Doesn't matter what you make y1 and y2.
you have to fix it. No, it doesn't. This is the way I label it. So you have to stay with this one.
Okay.
If you label it otherwise, you continue with yours. No, you get the same answer.
Okay.
Yeah. Okay. This would be, if you switch it, this would be x squared rather than negative x. Yeah. But when you go to the formula, it's going to be a negative. Yeah. Find negative somewhere else. Okay. That's no, doesn't matter. Okay. Now we are ready. Get the getting the u1. U1 is integral of negative y2 rx over the runs. Okay. So it's going to be negative y2. Y2 is x, negative x. R of x is x ln x. Divided by the Wronskian negative x squared. Negative x squared dx. Okay, just make sure you already normalize the R of x. So in this case, this is it. X times x would be x squared. So the top would be negative x squared ln x. The bottom one negative x squared dx. So these two will cancel out. Get integral of ln x, very popular. Ln x, x ln x, x squared ln x. They are popular for you. This is a Cauchy case, okay? And you know that you have to use the integration by parts to find it. And if you memorize it, we don't mind, x ln x minus x. It's going to, I think it's a minus x. But otherwise, you can do it, in 2 steps. If you remember it, that would be fine. U ln x, d v is going to be dx. So the du would be 1 over x, v would be x, or integration by parts. So ln x dx, integration by parts, uv x ln x minus v du, v du. There is a dx here, of course. Okay, so we have x ln x minus integral of the dx, which is x. So we accept that if you use it. Okay, integral of ln x dx is going to be the case. So this is u1. So the u1 is x ln x minus x. That's u1. Okay. So you may have x squared ln x, you can do the integration by part. But for all the integration by parts, you have to take u to be ln x all the time. U ln x, the leftover d of v, dv. Even you may have ln x divided by x squared, you move it up. X to the negative 2 ln x, then integration by parts. Okay, that's a u1. You have to go back and get the u2. Now what's a u2? U2 is y1 r of x over the Wronskian, okay? So y1 is x squared. Again, r of x is x ln x. Now divide by Wronskian, which is x squared. See now, if you simplify it, still we cancel out. So you arrive at x ln x.
Is the Wronskian negative?
Wronskian.
Yeah.
It's then negative, so there's gonna be negative. Okay, then you operate x ln x with the integration by parts again. Okay, that would be x squared over x squared over 2 ln x and minus x squared over 4, right? You can do it. So you have to take the u to be ln x again, if you want to do integration by parts. So the dv would be x dx. So again, the du is 1 over x dx, and the v is x squared over 2. Always take the u to be ln x. Now I put them together, integration by parts, x ln x, and u times v, which is x squared over 2 ln x. Is v du, v du, x dx. So 1x would cancel out. You get x squared over 2 ln x minus, it's going to be minus x half dx. So the x half is going to be x squared over 2 ln x. X half, integral of x would be x squared over 2. There is already 1 2 here, so that gives x squared over 4. That would be your u2. There's a negative sign, of course. So u is negative x squared over 2 ln x plus x squared over 4. So that would be, and this is the most you can have when you go with the Cauchy, okay, Cauchy-Euler equation. You know that for all the powers of ln, there is a formula. This is x, you see integral of x is x squared over 2. X squared over 2 ln x, then x squared over 4. If this is going to be x squared ln x, it's going to be x to the 4th over 4 ln x minus x to the 4th over 16 ln x. Is that the one that, you know, we have it in calculus 2? Not a big deal if you don't know it. You can find it, but be prepared. Okay, there you are. You have the u1 and u2, put them together, simplify it if you can, then you have the yp. Okay, so let's find out. You have to simplify the yp, the final answer. Okay, so there you are, yp. So the yp is u1 y1 plus u2 y2. Substitute. It's going to be equal to, okay, u1 that we got is x ln x minus x over y1 was x squared plus u2. u2 that we got, there was a negative sign, it's negative x squared over 2 ln x plus x squared over 4 times y2. And the y2 was x. Okay, multiply, simplify it if you can. So distribute this one, that give you x cubed ln x minus x cubed. Multiply this one, it's going to be negative x cubed over 2 ln x. And this would be plus x cubed over 4. Can be easily combined. This is 1 x cubed ln x, this is 1/2. So if you subtract that, you 1/2. Yes.
Isn't it minus x squared over 4?
No, so that was negative.
Negative.
It was a negative, we applied the negative sign to make it positive, okay? So this is going to be 1, but this is 1/2, so it's going to be plus 1/2. And this is a negative 1 plus a quarter, okay? Negative 1 plus quarter, that gives me negative 3/4. 3/4 of the x cubed. So that would be your yp. Or we can say c plus yp. That gives you the solution of the nonlinear equation. Okay, the procedure, okay, it takes time, so you have to manage your time. These two true. Okay, so that is the case for the Cauchy-Euler. Just practice a couple of them would be fine. You know the idea. And we prepare for that integration by parts. Okay, so that will take us to the nonlinear case. Remember, we have two cases, nonlinear equation, the case that y is missing and the case that x is missing. You want from each. Okay, try to give you something easy, put them together quickly and get the result. You have quite a lot over here. It's all very similar to the one that I did. Okay, so I'm going to pick the two of these to explain it for you, one from each. The first one is very similar to the one that we did, but just solution of all of them. So number 6, solving nonlinear equations. We solve each nonlinear equation. Two cases. Okay, so there you go. One from these two explain it. Okay, so part 1 is y double prime plus y prime squared equal to the 0. See this one? You check to see which variable is missing. In this case, variable, okay, x is missing. Variable x is missing, it takes a little bit more time. Good. Okay, and the y is missing, it's easier. So, no, both of them are easy, of course. So there you are. You have to identify which case is it. Case 1 or case 2. This is case 2. So the variable x is missing. This is where you have to create a new differential to be able to do it. So what we're going to do is we are going to suppose, okay, you suppose that y prime to be equal to the u. But remember, y double prime would be what? Y double prime would be u du dy. See, because you don't have the x. When you don't have the x, you cannot talk about the du dx because there is no x. So what you do is you change it to the equation in terms of the u and the y. So that's why you have to create du dy to be able to do it. That's a format. But if you're going to do the other one, y prime u, y double prime u prime, you'll be fine. Because all the primes are derivative with respect to the x. That is the nature of this problem, okay? Now, if you substitute, it's going to be something straightforward. So this is the equation, y double prime as y prime squared equal to the 0, okay? Now substitute y double prime is u du dy. That's the case, plus y prime squared, u squared, equal to the 0. See? Easy equation to solve. Any suggestion? How can I solve this one?
Separation of variables.
Before that, something to do before going to separation variable. You can divide by u. Okay, you can assume that u is not 0, because u is u prime, it's going to be 0 constant. So if you get a chance, do these, okay? So that give you y du dy plus u equal to the 0. Now make it easier. Now, yes, it's a separable variable. Just move it to the other side, separate it. Okay, that's going to be the case. Put the u's and the y's together. Okay, you can cross multiply it and then do it. So this is going to be the case. Okay, so I put the u here. So the y is this one. Okay, if you cross multiply, you get the same things. So both of them are natural log. So this would be ln of what? ln of the absolute value of u And this would be negative ln of the absolute value of y. And there is going to be a constant, okay, a constant c here. You may call it C1, okay? You may call it C1 over here. You see, if you get this part, there are sometimes you can make it easier for yourself. If this C1 happen to be LNC, doesn't matter, you can call it LNC, LNC1. Because if it's getting ln, then you can simplify it. So think about the next step. Because the next step is you have to solve for u and then replace the u by y prime. So these type of tricks are going to be possible, okay? So what I'm going to do is, so you can take the e of both sides if you like. That's one version, and the other version is going to be this one, okay? Just repeat it here. That I have a different method to do it. This is ln of the absolute value of u equal to the ln of the, okay, what's this? Ln of the absolute value of y plus c1. You can take the exponential if you like, call it e to the ln of, you can even drop the absolute value. And that would be e to the negative ln of y plus c1. Okay. Then e to the ln u, you know that it's going to be u. This one, you can break it into the negative ln of y and the e to the c1 if you like. So this would be u equal to, this first one would be what? You move the negative to the top. It's going to be ln of 1 over y. And even you can replace this one by c1 again. It's a constant, e to the c1. So that gives you u equal to the 1 over y, c1y. You see, that's one choice. So that's something trick that we can do to simplify it, to get this true. Okay, the other option is, this is C1, you call it LNC, then you have difference between the ln, you change it to the quotient. See, the other option is, you have the ln u equal to the negative ln of y, you can call this one ln of C1. Then that give you what? ln u, this is going to be a difference between two ln would be quotient. Then use one-to-one property of the ln, you arrive at the same thing, C1y. So two different options, okay? Because you have to continue now. You take the u to be equal to the y prime and continue. So u is y prime. So y prime is C1y. Replace the y prime by dy dx, which is going to be C1y, and continue to solve the problem. Cross multiply y dy is equal to the C1 dx. Okay, C1 dx. Y dy is going to be C1 dx. So that gives you y squared over 2 equal to the C1x plus C2. You can multiply both sides by 2. So again, y2 would be C1x plus C2. So that gives you the final answer. This one is true. Okay, that's it. That's all I have time, but I will post the solution with you. So get practice, okay? And it may give you something like, one from each. It's probably 8 or 9 questions. But I'll be here 30 minutes early if you want more time. Okay, have a nice one. Thank you. Take care. I have a recording of this one separately. And after your test, you briefly talk about the one method, we call it solving differential equation by series. And then for the rest of the course, it's left.
pull up CS Club.
Oh, dude, that'd be sick.
That was so close. Costco pizza?
Yeah, you missed out on Costco.
Came with Costco pizza and Costco cookies. It was good. It was good.
Do you normally have to wait for
I
that?
fucking missed it.
Yeah. Are you gonna go? What to pull up with Caesar's, bro?
Hey, Isaac, I just sent the file over.
Thank you.
No.
Yeah.
Yeah, I'm sorry, because. Generally, because this is the baby. Okay? Your quiz? Yeah. Okay.